Good morning. I welcome you all for a session on structures in C programming. What are structures? Right at the time when we discussed data types, we came across three different categories of data types, what we call as number 1, primitive or built-in, number 2, derived data types, and number 3, user-defined data types. Primitive ones are like integers, characters, and floating point numbers. Then we have derived ones like your array, and the last category of your data types happen to be user defined. That is, whenever you are not satisfied with your primitive ones or with the built-in ones or with your derived ones, we go for creation of structures. That is, the basic thing with your primitive data types is it can hold a single datum separately. Something with your derived data types would be holding up these primitive data types together, but only one particular data type together. Now, if there arises a need where I will have to have a couple of different data types to be stored together, I need to go for structures. So, in this section, we will have a brief discussion on various structures we can make use in C. To start with, what are structures? Structures are collections of related variables, all grouped under a single name. So, this is going to be a collection of different data types which are tied together under a single name. It can contain variables of different data types. These are commonly used to define records to be stored in files. Say for example, a student record may consist of different fields. Say for example, his name, which should be in characters or character array, his name, his number, his age, his marks, and few other information that relate towards a student, which together constitute a record. If you have a close look at these different fields in a record, they all will be in different data types. So, we hold them together under a single name of a student and we call that as a record. Sake of this record creation needs the help of structures. Then these structures can be combined with pointers. They can be used to create different data structures like lists, stacks, queues, and trees. So, these are some small examples of having structures in our program. Let us now look at a simple structure definition, or we can have a simple example for a structure definition. Every structure usually starts with a keyword called struct. This is the word that indicates the compiler that the thing that is going to follow is a structure. Then it is followed by a structure name, and this structure name follows the rules that we have for an identifier. Then you can have any number of members you can or you think are suitable for this particular kind of a structure. This starts with a opening curly brace and it ends up with a closing curly brace, which is punctuated by a semicolon. Struct introduces the definition of the structure for a card. Card is a structure name. It is used to declare the variables of the structure type. It consists of any number of members as this application demands. This is what we do have in a normal structure definition. What is the peculiar feature about this struct information? A struct cannot contain instances of itself. A structure can never have instances of its own. That is, I cannot have an instance of card mentioned within this structure itself. This is not possible. It can contain a member that is a pointer towards the same structure type. Imagine it cannot contain an instance of itself, but rather can contain a member that is a pointer to the same structure type. Then these structure definitions does not reserve any space in memory. The structure definition does not reserve any space in memory, remember, but the structure occupies some space in memory. It creates a new data type that is used to declare the structure variables. This is the important thing that we need to understand. It creates a new data type. That is why we say that this is a user defined data type that is used to declare structure variables. If we are going to make use of integers which are primitive data types, we make it as int a, b, c. But the definitions for integers are coming built in with your compiler. But unlike those, we need to create the structure data type by our own, for which we define our rules. That is why we say that we create a new data type that is used to declare structure variables. Fine. I have defined a structure. How can I declare variables for a structure? It can be declared like anything. It can say that a card C, which means that you are creating a new member or a new variable C which is of type card. You can use a comma separated list, or you can make use of a normal declaration that ends with a semicolon. These are the various points that need to be noted for a structure definition. Apart from this, what are the valid operations? If you can remember our days on data types, we told you that a data type tells you about 4 different things. Number 1, the type of data. Number 2, the amount of memory it occupies. Number 3, the range of values it can hold. And at last, the operations that are possible on data. Say for example, for integers, it happens to be the type happens to be integer. The space happens to be 2 bytes or 4 bytes depending upon your machine. The range of values happens to be between -32768 to +32767 in case of 2 bytes of integers. And at last, addition, subtraction, multiplication and division and model division are the available operations on integers. Likewise, the structure that we have developed should also address all these 4 avenues. It has told us that it is going to be of type card. It is going to occupy the memory equivalent to the members of your structure. The range of values you can hold is going to depend upon all these things. Then what are the valid operations? Assigning a structure to a structure of the same type is a valid operation. Taking the address of a structure is a valid operation. Accessing the members of the structure happens to be an operation. Using the size of operator to determine the size of the entire structure can also be a valid operation on a structure. I repeat again, assigning a structure to a structure of the same type is a valid operation. That is, I create 2 instances C and D. I can have some operations like C equals D, which means that I am going to assign a structure towards the structure of the same type. Then taking the address of a structure is possible because it has a number of members. The address of its first member happens to be the address of your entire structure. This address can be taken out from a structure. This is a valid operation. Accessing the members of an structure happens to be another operation. Then you can make use of the size of operator to find out the size of your entire structure. These are the valid operations we have on structures. Moving on towards initialization. I have declared, I have defined, and it is now time to initialize my structure. What is it I can do? Imagine I have 2 members on this entire structure. How can I pass values for it? It is as simple as this. Imagine you have an integer variable declared as int x and you say that x equals 10. This is in case of your primitive data type called integer. Now you have created your own data type by the name card. So what is that you do? It is card C which equals, imagine I had 2 string members over here. I can straight away say that this is the first string and this is the second string. This is how I would pass or initialize values towards my members. Then assigning statements. You can create a new instance and you can say that a value is moved into a member value. Then you can have some dot operator to initialize values for it. Say for example, I have a structure with the name card and it has 2 different members called as face and suit. How do I move value towards an instance C of a structure called the card and I want to access the member face? It is as simple as this. I place it as C dot face equals a particular string. C dot suit equals a particular string. This is how I have assignments towards the various members in my function. Then how do we assess the members of structures? I have a special operator called a dot operator which is used with my structure variable name to access all my members. Imagine this is my structure and this is my structure variable name, what I call as C. This can be used with a dot operator followed by the member name to access or to place or assign values for my particular member. Then I have an arrow operator which is equivalent towards my dot operator. I can have an arrow operator which is a combination of a hyphen along with a greater than symbol. An arrow operator uses with pointers to structured variables. Imagine I have a pointer variable for this structure. I have an address. Then I want to point towards a particular member in my structure. Then I can say that my structure variable dot the member name can easily access that particular member. So this is how I have access towards the various members of my structure. Now, how can I make use of structures with functions? We can pass the entire structure towards functions. Is it possible to pass the entire structure as a parameter towards your function? Yes, you can still pass an entire structure towards a function, or you may even pass an individual member towards a function. Both these passes are following call by value. Then to pass structures by call by reference is also possible. It simply passes its address or it passes the reference towards it. Then you can also pass arrays by call by value. You create a structure with the array as a member and you can pass the structure. This is how you can pass arrays, or you can pass it to arrays for call by value. These are the simple different things that we have with structures. An important thing that comes into our mind when we talk about structures is termed to be type definition. What is type def? It creates synonyms for previously defined data types. This type definition is used to create shorter type names, right? Say for example, right at the time of our enumeration itself, we have noted the difference between enumerated data types and type definitions. So type definition does not eventually create a new data type, rather it creates aliases of something that is existent by some other name. Say for example, if it is hard to understand something as int, you can rename it as integer. The only thing is type def int space integer gets you an integer known by another name called as integer. This is what we do have as type definition. Then we can have several different simulation examples which have a structure implied onto it, by which you can improve the efficiency of your program. This is how we do have structures in C programming. A notable point over here is whenever I try to allocate a space for this entire structure, the total space that gets allocated is the sum of spaces required for all my independent members. So when I take this particular structure called as card, and if I make use of two different strings which are of 10 characters each, then the space occupied by this entire structure happens to be 20 bytes. So that is a major point that we have to note about a particular structure. Then we move on towards unions in C programming. What is union? A memory that contains a variety of objects over time is said to be union. It only contains one data member at a time. This is a notable point about an union. Imagine the case of a structure. This entire structure allocates spaces for all members of its structure. But in case if you replace this struct by a keyword called union, it won't allocate spaces for all its members, but it contains only one data member at a time. Members of a union share their spaces. It conserves storage, by which we can argue that it has an upper hand at efficiency. Only the last data member defined can be accessed. These are some of your pluses and minuses of having an union. And union declaration is the exact same of a structure. The simple thing is you replace the word union, replace this word struct by union. This is a declaration that you can have for union. After this, anything is going to be similar as like that of your structure. You take upon valid union operations. Assignment of an union of the same type as like structures. You can take addresses, you can access an union member, you can access a member using a pointer, what we call as a dot operator. These are all possible with unions. You can have a sample C program which can easily prove you a structure along with a union solving a same application. So, these are the various structures and unions we have in C programming.